Wastewater treatment plant engineering solution to water crisis. This research was made by Alan Christian S. Salvatierra, Alexis B. Dequino, Michael Josh Leviste, Jenner Olleres, and Kimball Manimtim. Introduction.
Water to fuel life. Humans rely on water in different ways. Although 70% of the planet is covered with water, only 0.007% of it is the fresh water that can be used to hydrate and nourish its billions of people. Fresh water is commonly used in daily life, agriculture, industry, commerce, energy, and recreation. And it is expected that by year 2040, the demand for water will increase by 50%.
Water scarcity. However, the world is already facing water scarcity. It is also a major problem in the Philippines, in where a report made by World Health Organization revealed that 1 in 10 Filipinos still do not have access to improvised water resources. The ability of urban communities to obtain enough clean and safe water for daily usage is becoming more and more challenging as a result of these changes.
Engineering solution to water crisis. An article published by Born to Engineer stated that one of the engineering solution to aid water crisis is through wastewater treatment plant.
History of wastewater treatment. The Mesopotamians were the first to formally address sanitation by connecting homes to a drainage system that could carry away waste around 3500 BC. Then the Romans perfected their sewer. The sewer system in Rome was expansive and had many small channels that flowed by gravity to larger channels. The 90s witnessed a revolution in wastewater management as scientific understanding and societal priorities started to decrease unhindered pollution. This period set the foundation for modern wastewater treatment.
Wastewater. Water that has been contaminated by domestic, industrial, or commercial use is referred to as wastewater. It commonly comes from ordinary living processes like flushing, laundry, dishwashing, and etc. The composition of wastewater is 99.9% water with the remaining 0.1% removed. Organic matter, microorganisms, and organic compounds make up this 0.1%. The other pollutants found in it are bacteria, viruses, and diseases-causing pathogens.
Wastewater treatment plant in civil engineering. The design of the water treatment plant and city sewage system is a more common wastewater civil engineering work. Civil engineers in this job can perform a variety of tasks, including directing the licensing and permission application of wastewater treatment films. Civil engineers also work with the state agencies to ensure that the wastewater treatment plant complies with legal requirements.
Wastewater treatment plant in subdisciplines of civil engineering. In water resource engineering, according to Riverside, wastewater treatment plants is part of water resource engineering since the quantity and quality of wastewater from municipal areas usually exceeds the assimilative capacity of receiving natural waters. Collection and treatment of wastewater is required to keep the water resource clean enough. Much of wastewater produced by homes, business, and industries must be treated. Wastewater treatment plants have the ability to remove suspended solids and toxins in used water. In environmental engineering, environmental engineers also design wastewater treatment facilities to treat water so that it won't negatively impact the ecology and downstream users.
Wastewater treatment plant in other type of engineering. Just like in civil engineering, wastewater treatment plant was also part of sanitary engineering. Sanitary engineering is also known as wastewater engineering, in where they involve the use of mechanical, biological, and chemical operation to achieve and maintain excellent water quality on a daily basis. It primarily deals with the transportation, treatment, and management of contaminated water. Sanitary engineering works on projects of all scale, from designing small package plant to large municipal and industrial treatment facilities, pumping station, reservoir, distribution system, and sewer. But how can wastewater treatment plants help in solving water crises? Research question. The aim of the research is to find out how can wastewater treatment plants help in solving water crises and the relationship between the amount of treated wastewater produced by the wastewater treatment plants and reducing water crisis. Specifically, the researcher tries to answer the following research questions. 1. Profile of the respondent. What is the profile of the respondent in terms of the location and name of wastewater treatment plant? 2. Role of wastewater treatment plant in solving water crisis. How can wastewater treatment plant help in solving water crisis? What are the different processes involved in treating wastewater? 3. Relationship between the amount of treated wastewater produced by wastewater treatment plant and reducing water crisis. What is the amount of treated wastewater produced by wastewater treatment plant monthly? What is the monthly treated wastewater's equivalent contribution in reducing the city's water crisis? Significance of the study. There were limited studies regarding the possible role of wastewater treatment plants in aiding water crisis. That's why if the research proved that wastewater treatment plant could really help in solving water crisis, it would benefit the society and the future researcher. The community would be aware that wastewater treatment plants can be also used in combating water crisis. Thus, they would use it and improve their existing plants. It will also benefit the future researcher as the research will serve as a guide to other researchers who would like to pursue the same study for the study's further development. Research design.
The study employs a mixed method. In mixed method, team of researchers combines aspects of qualitative and quantitative research approaches in collecting and analyzing data to understand the research problem more completely. Since it is a mixed method, the research utilizes two research design. Descriptive research design is employed for the qualitative approach, while under quantitative approach, correlational research design is utilized.
Research instrument. Interview and structured questionnaires were used as the research instrument. Interview will help the researchers to gather qualitative data while structured questionnaires will be responsible for collecting quantitative data. There are 5 questions that is related to wastewater treatment plant and water crisis.
Data gathering procedure. Data gathering is done in person. It was conducted at the sewage treatment plant of the 5 cities of Batangas region, which are Lipa City, Calaca, Batangas City, Santo Tomas, and Tanawan. The researchers asked permission to carry out the study. When the request is granted, the researchers visit the treatment plants and ask every treatment plant managers to be representative of their city's treatment plant. In conducting the structured questionnaires, the respondents were given a printed set of questions. While in conducting the interview, the researchers record the answers of the respondents through audio and video recorder.
Data analysis. 2 data analysis method is used, one for the collective qualitative data and one for the collective quantitative data. For the qualitative data, content analysis is employed. For the quantitative data, researchers use inferential statistics. Under it, hypothesis testing is utilized. The purpose of hypothesis testing is to evaluate relationships between variables. Researchers also employed Microsoft Excel spreadsheet for the data analysis.
Hypothesis. Null hypothesis. There is no significant relationship between the amount of treated wastewater produced by the wastewater treatment plant and reducing water crisis. Alternative hypothesis. There is a significant relationship between the amount of treated wastewater produced by the wastewater treatment plant and reducing water crisis.
References. That would be our research proposal. Thank you.